This particular project, News IT, began really with our reflections in Xiaomi's about what our priorities would be in any technological development. How would we develop for Xiaomi music science and technology for the use of people with disability? During the pandemic, people with disability seemed to have to suffer even more than everybody else. And of course, we tried to use technologies, but Zoom was no good. There's a terrible delay. You can't play with people on Zoom, and the sound is awful. And the same goes for most of those platforms. So could we create a platform that would enable people with disability to work together at a distance? And this was the beginning of our platform for co-creativity. And we were lucky because we had, as one of our team, Patricia Alessandrini, composer, and Patricia being very closely connected at that time with Stanford University in California, where they were working on exactly the kind of platform we needed. It's called JATRIP. It's an architecture that allows people to play with no delay, or is it near to zero delay. So we decided to build on that. Then, what was missing? What was missing was what people share when they're close together. They share their emotions. They share their physical gestures, their facial expressions, all kinds of things we share when we're close together. So how could we get that at a distance? So we looked at the possibilities of sharing emotions and states of mind and body.
Today, we're going to talk through the remote co-creation platform that we have built as part of the News IT project. The remote co-creation platform allows you to make music with someone who might be very far away, with very low audio latency, and with additional features that add to this musical experience through things that we're calling emotional communication or communication of states of mind and body. And these states are communicated through various different modalities that we'll talk you through today. So one of the core components of the co-creation platform is JATRIP. JATRIP is a technology developed by Stanford, by a man called Chris Chafe primarily. And what JATRIP does is it's a protocol for sending audio at very low latency. So typically over Zoom or over other Teams, Microsoft Teams, Google Meets, you're typically seeing latencies up to about 100 milliseconds. But for musicians, for us to be able to play in rhythm to synchronize, we need to have latency, less than about 25 to 30 milliseconds. So on top of JATRIP as a audio transmission protocol, we're also thinking about how we can allow musicians to communicate their states of mind and body to other musicians very far away. When you're in the same room as someone, this can be quite straightforward. As human beings, we've evolved over thousands of years various subtle mechanisms for picking up on how someone in the same room as you is feeling, even if they're not necessarily telling you how they feel. In music, we may be expressing those emotions musically, but it's also playing with someone in a physical space. You also rely on these other indicators. Moving to an online space, a certain amount of that is just lost. We can't get it back. But the question we were asking ourselves in this project is how can we use technology to kind of fill that gap? What new things can we introduce, that might be interesting or add to the space, and specifically, in the context of inclusivity and accessibility, what can technology offer there as well for people who are maybe not able to participate in traditional means. Communicate states of mind and body, we need to understand what we mean by that. What are we measuring here? And in this project, we are primarily working with two variables called autonomic arousal and autonomic valence. And very roughly speaking, arousal is how neurophysiologically activated you are. So if you're very excited, if you're doing sports, or you're very energetic, or just otherwise excited, or perhaps anxious and very stressed, you would say you have high arousal. You have high level of neurophysiological activations to do with your nervous system. And valence is the complementary parameter, which is basically asking the question, is this activation, roughly speaking, is it positive or negative? Now, obviously, in the context of musical performance, we're being very fluid with these ideas of emotion, acknowledging that as human beings that we, smoothly navigate this emotional space, all the time. And especially during a musical performance, it might be, more noticeable than at other times. So how are we predicting these? Well, actually, we have a few different ways of doing this. So using our platform, we currently have 3 different sensors integrated into the platform. This is EEG, it's measuring your brain waves, ECG, which is measuring your heart, the electrical activity in your heart, and we have obviously a webcam, which is watching your face. So we come to our partner technologies. We have, thanks to our partners in CERT, we have a technology that from EEG predicts both arousal and valence. And this is an AI algorithm. It's using a neural network trained on data of people looking at artwork and listening to music and, subjectively evaluating their arousal and valence while doing that and measuring their brainwaves while doing that. We have another way of doing this, which is through our partners in Catalink. We have their stress detection algorithm, which uses your heart rate to directly predict your level of arousal. And complementary to that, also from Catalink, we have their mood estimation algorithm, which is predicting valence from your facial expression. From how the happy or sad you're looking. So from these, this is now working locally on your machine in the co-creation platform. If you plug in a combination of these sensors, we can predict your arousal and valence. So the next question is, what do we do with those predictions? And now we come onto the last category, about emotional representations. And we've got 3 here as part of the platform. We have a dot swarm visualization, which we will show you shortly. We have music generation, and we have haptics. So, one thing that can happen is that we use arousal and valence to manipulate this dot swarm visualization. So it's a swarm of dots of different colors, and the colors and the way they're moving is changing depending on arousal and valence to provide an abstract depiction of different emotional states. And notice here for these lines, we're passing through this squiggly thing, which is representing the fact that we're now moving from your local machine over to someone else's system. And this other person may be in the same city, the same country, or maybe a completely different continent. And over, JATTRIP, we have this protocol for sending audio over the internet. Additionally, as part of the Muse IT project, we've built a data channel into this. So as well as sending audio, we're encoding this data, and it could either be these derived emotion parameters or actually raw sensor data. It's a very flexible channel. So now in this context, say you're sitting in one place and say you have the EEG cap on, it's predicting your arousal and valence, and that's being communicated to someone else, and they're seeing on their screen the swarm of dots is changing depending on your arousal and valence. So that's one modality of emotional representation. Another one we have is music generation. So through an algorithm developed by Catalink, we can generate music based on the changes in your arousal and valence. And so the way their algorithm is working is changes in arousal can affect note frequency, and it can also affect interval direction if the next note is going to be higher or lower than the previous one. And changes in valence affect the harmony. So it may change, from the harmony from a major chord to a minor chord. These will change depending on the valence. And through that, as your arousal and valence is changing, you are generating music from, the state of your body and emotion. So that is our another pathway. Now we have some different pathways in the system. We have something interesting here. We have EEG going straight to music generation. We have another system for generating music, and this time not through these derived emotion parameters, but directly from EEG, in a combination with a program called SOMAX, which was developed by Earcam. And so how this works is we first take your EEG brainwaves, which are, they're waves just like musical waves. They're just at a much lower frequency. And so as a first step, we pitch them up. Basically, we take them up about 6 octaves, so they're in the audible frequency range. And at that point, you can hear your own brain, which is it sounds very strange. It's very kind of loud and noisy and chaotic. But we can use that audio signal with Somax to actually trigger a real instrument like a violin or a saxophone. And Somax works as basically a library or an indexing system for an audio sample. So you feed into Somax a recording of someone playing the saxophone or playing the violin, which is a linear recording, and it takes that and it sort of detemporalizes it. It takes all the little musical phrases and excerpts that are present in this recording, and it kind of puts them into a library, and it characterizes them by a lot of different parameters. Basically, how does this musical phrase fit in the space of all possible musical phrases, and so that's something called a corpus. And once you have a corpus, you can feed a corpus in with an influencer. And what an influencer is a separate audio stream that comes in. And Somax is reading that audio stream in frames, and every frame is asking the question, it's looking at its library and its corpus, and it's saying, hey, is there something that's similar to this? Is there something similar to what we're hearing? And based on that, it may decide to play something from the corpus. So in the context of EEG, we're feeding it in an EEG audification, so it's listening to your brain, and it's deciding if it's going to play a musical sample, if it's a close enough match to what is happening in your brain. This may sound very complicated, but the effect is basically you wear the EEG, and you may be listening to someone else play music, you may be part of a musical session, or you just may be sitting quietly by yourself, and the system will start to play an instrument of your choice based on your brain activity. And the final indirect pathway we have is from ECG to haptics. So as also part of the platform, we have a haptification of the heart. So someone very far away can hold a haptic actuator, which will actually, vibrate like your heart. It can feel like it really feels like you're holding someone's heart. And this can be a very powerful experience, and it's one of the, modalities that we have in our platform.